Hello everyone, welcome to this session. We are still discussing about the secondary cells, also known as the accumulators. So far in our previous video, we saw the mode of structure of this accumulator, specifically the lead acid accumulator. So today, let's move on to the charging and the discharging phenomenon on the accumulators. The charging simply is done by connecting across its place as source of direct current. So you can charge the various accumulators simply by connecting across its place as source of the direct current. Now, if the current of the 2 ampere can be allowed to flow across the terminal of the cell, now the positive terminals of the cell and the source of the current, that is the dynamo, must be connected together. Similar, the negative terminal must be connected together. So that have to be noted when you're trying to charge the accumulators. Now, if the cell is now fully charged, the potential difference PD across its terminals on the open circuit is 2 volts, and the cell is ready for use. So that's how it is after fully charged. The accumulators are is ready for use, and the open circuit is about 2 volts. Now it can light simply says a 2-volt electric lamp connected across its terminals, and the currents will flow in the reverse direction to the charging current. Now let's see the discharging accumulator. Discharging, this is the process of using the charges stored in the lead acid accumulator. Now when the accumulator is discharged after long use, both plates they become coated with the lead sulfate. So this is what happens when the accumulator is discharged after a long use, which means that the various both plates that are within this lead acid accumulator, they become coated with the lead sulfate, and the relative density of the acid also becomes less, and the potential difference of the cell falls. So generally here we're trying to discuss the charging and the discharging of the lead acid accumulator, as we previously discussed the mode of structure of this lead acid accumulator. Now, the recharging process will restore the plate of the lead oxide, and the lead and the relative density of the acid will rise to 1.25. So the recharging process has to be done, and the recharging process, when it occurs, it will simply restore the plate of the lead oxide and the lead component and the relative density of the acid that is within this lead acid accumulator. The accumulator, it must not allow to discharge below the stated values of the potential difference and the relative density, or it will simply not be possible to recover its own recharging. So you have to note that when you are using this lead acid accumulators, whereby the accumulator, it must not be allowed to discharge uh, completely or below the stated values that are required for the potential difference and the relative density, or simply what will happen that it will not be possible to recover it from the recharging process. The capacity of the accumulator is the amount of the current in amperes that the cell can send throughout a circuit, and is measured in ampere hour. So thus have to be noted the capacity of the accumulator, which is simply the amount or the measure of the current in amperes that the cell can send throughout the circuit, and it's the one that is measured in ampere hour. Now, the charging rate accumulator is a current in amperes, numerically equal to 1/10 of the capacity required in recharging. The lead acid accumulators have high EMF, that is 2 volts per cell, and allow internal resistance. And the accumulators are best cared for by a regular check of the level of the sulfuric acid, just to preserve them for longer use. And any loss due to evaporation, it must be replenished with the distilled water only. You cannot use any other water apart from the distilled water. And no acid should be added unless there has been same spillage from the cell. So you can't you can't add another acid unless there's been some kind of spillage from the cell. Accumulators also must be recharged regularly using the charging current recommended by the manufacturers, and they should not left in this discharged condition just for a long time. So you cannot leave these accumulators, lead acid accumulators, just for a long time without charging them, unless otherwise they will collapse. Now, when not in use, these lead acid accumulators, they should be recharged at least once every month, and the accumulator should never be short-circuited. Shorting the cell may cause swelling and the buckling of the plates due to the excessive heat developed in the cell, leading to the permanent damage, whereby a cell in this condition is said to be sulfated. So that's all I have for this session. I hope that's clear. We briefly discussed the charging and the discharging of the lead acid accumulator as one of the secondary cells. I hope that's okay, and thank you.